Hello students. So in the last class, we have discussed about mass spectra. This is the important point. That is ring rule, even electron rule, ring rule, and nitrogen rule. So this is finished in the last class. So in today's class, we are going through the application part. This is the very important. Normally we are taking mass spectra because of this reason. That means the spectra of some compound. That means we can identify the compound by the mass spectra. So here with the example we can easily understand how mass spectra is works here. So first thing, the first example, the mass spectrum of water. So here the mass spectrum of water, then mass spectrum of ammonia, mass spectrum of methane, mass spectrum of ethyl bromide, and mass spectrum of ethanol. So this much of example you have. That means 5 example you have. In these 5, one question is compulsory in your question paper. So this is 4 marks question, very important question, and it is very easy one. So it is very easy one. So here we have the graph. This is the graph of mass spectra of water here. So in the graph, you can easily understand the overall picture. So here the 18 is the base peak or molecular peak. Here 18. What is 18 here? So as I explained in the last class, the 18 or molecular mass of a compound is 18 here. And then we have 19 and 20. Okay, here the intensity, the height of the peak here. So here, this is the height of the peak, which indicates the intensity of the compound here. Okay, and then we have the fragmentation here. Yes, first thing, the height of a molecular weight peak of 18 is a 100%. We have to take the intensity of molecular ion peak or base peak as a 100% here, and here we have the 18. Then what is 19 and 20? So this we have to understand, and then it is 16. So this is 16. So first go through the explanation here. The base peak is observed at m by e of 18. So the base peak is m by e of 18. So for the explanation of any of these 5 examples, you have to write like this only. The first point, you have to identify the base peak. This is the steps we have to follow. The first step is we have to identify the base peak. So we have to write the 18 is the base peak. So this is the base peak. And then how to identify the base peak? Which one has the highest intensity? That is the base peak here. Then next one is the fragment ion peaks. So next step, in the next step, we have the fragment ion peaks are found at 17 and 16. So here we have the 16 and 17 as a fragmentation peak. That means here the base peak, that means parental ion peak, they undergo further fragmentation. So, and it gives their daughter fragments. So this is the 16 and 17. They are the 16 and 17. They are the fragment ion peaks here. Then next one is isotopic peak. So here to identify the base peak and to identify the fragment ion peak. And third one, if they have any isotopic peak. If they have the isotopic peak, then we have to identify their isotopic peak. So here we have 2 isotopic peak. So there is one is 19 and one is 20. So it is the intensity is very low. That means it is negligible, but we have the isotopes here. Here one isotopic peak and here another isotopic peak. So that means it means the base peak at EE 18 itself is the molecular ion peak. So here the 18, it is a base peak also 18 and the molecular ion peak also 18 here. So this is given by the spectrometer. Okay, you don't do mass spectrometer, it will give the information of base peak and molecular ion peak here. And therefore, the molecular mass of the compound must be 1920. Okay, therefore, the molecular ion peak, that means if the after the molecular ion peak, if we have any peak means it's always the isotopic peak. So as I said in the fourth point, the base peak and the molecular ion peak are same. So here 18 is the base peak and molecular ion peak. So in the next 19 and 20, after the molecular ion peak, you have other two peaks. So these two peaks are the isotopic peak. What is molecular ion peak? So here, or molecular ion peak means the compound which we are introduced in a mass spectrometer, they have the maximum of molecular mass. So what the maximum molecular mass means? The compound with the highest molecular mass, that is the parent ion, that is what we call molecular ion peak. After the molecular ion peak, if we have any other higher molecular mass means it is not the molecular ion peak, it is the it is the isotopic peak. So here 19 and 20 is the isotopic peak because 18 is the molecular ion peak. So 19 and 20 is the isotopic peak here. So therefore the molecular mass of the compound must be 19, 20, be 18. That means here the molecular ion peak is 18, and then compound with the 19 and 20, they are also molecular ion peak, but this is because of the isotopes of their compound. That means in the compound they have the isotope. So it gives the idea about the compound which have the isotopic peak or isotopic atom they have. So here normally the isotopes are very rare in the periodic table, so we can easily identify. For example, if they have the isotopes means it may be the compound may be contain nitrogen, oxygen, carbon, hydrogen, and like this we can identify from the isotopic peak. That means the limited compounds have the isotopes of their compound, so we can easily identify some of, or we can guess some of the compound like oxygen, they have the isotopes, and then carbon or the hydrogen, like this we can identify, and bromine also have the isotopes. So this type of compound we can expect here. Okay, and then this is the first point about the isotopic peak. And then second point, the abundance of the isotopes. For example, we have the carbon in a compound, we have the carbon, then we can go through the isotopic peak. Then in the isotopic peak, the carbon 12, carbon 13, and carbon 14, these are the isotopes. These are the isotopes. And if we have the three peaks, just imagine if we have the three peaks in a spectrum, then carbon 12 is highly abundant in nature. That means in the 100% of carbon, that means 100 gram of carbon, only 1 to 0.1, that means very limited, negligible amount of carbon 13 is present. That means the carbon 12 which gives the highest intensity, okay, but the intensity of carbon 13 is very negligible compared to carbon 12. So here on the basis of the abundance uh, we can guess the compound. Or one more thing, there is bromine. If we have the bromine as a isotopic peak, in the bromine 79 and 81, two isotopes we can expect. So they have the 50% of abundance. So they have the 50% of abundance. That means they which gives equal intensity lines. So if it is the bromine's isotopic peak, then 50% of bromine 79 and 50% of bromine 81 we can expect. So this is the isotopic peak. And if we have the chlorine, then 25% of bromine 35 and 75% of bromine, 37 we can expect. So their peak will be one peak will be expect like this. So on the basis of the abundance of isotopic peak, we can expect the different type of atom in an compound. So this is because of this reason the isotopic peak is very important in the mass spectra. So this is just an example. In the further example, you can easily understand the importance of isotopic peak. And now, since the molecular mass is even, the presence of nitrogen, so nitrogen in the molecule is ruled out. That means from the nitrogen rule, we are already discussed here, nitrogen rule. So on the basis of nitrogen rule, if the compound have, if the compound have even number of molecular mass, okay, even number of molecular mass, then we can expect a even number nitrogen. That means even number means 0, 2, 4, 6, 8 like this. So here the compound with the 18 as a molecular mass, then we can expect no nitrogen here, or we can expect two nitrogen. But its molecular mass is only 18. So if we have two nitrogen means it's normally the molecular mass of compound is more than 18. So we can rule out the first nitrogen rule here. That means there is no, we can easily understand there is no nitrogen here. Why? If we have the nitrogen, even numbered molecular mass means they must have minimum means two nitrogen or no nitrogen here. So if they have minimum two nitrogen means their molecular mass must be more than 18. So here we can rule out the first nitrogen. So we can easily say there is no nitrogen here. So then in the isotopic peak, we can expect two isotopic peak. They are M. M means what? Molecular ion. So peak, that is, this is M. Okay. We have two isotopes here, M plus 1 and M plus 2. M plus 1 means 18 plus 1, that is 19. Here it is the isotopic peak. And M plus 2 means 18 plus 2, it is 20 as a isotopic peak. In these two isotopic peak, the element of hydrogen and oxygen must be present. So on the basis of the isotopic peak, we can say we have two elements. So that is hydrogen and the nitrogen. Sorry, hydrogen and the oxygen are the two peak here, because the oxygen have the isotope of oxygen 16 and oxygen 17. That means M and M plus 1. So here this is M plus 1 peak. This is because of the oxygen 17. That means it have the isotope of 17, 16 and 17. So 16 plus 1. So M plus 1. So it is here the isotopic peak of oxygen. So then the oxygen must be present in the molecule. The proposed formula for the molecular ion H2, the M plus, that means M is the molecular ion peak plus 1 peak at 19 due to hydrogen 17 oxygen. That means oxygen is the 17 molecular mass. Then M plus 2. So this is because of the oxygen of 18. So here the oxygen with the molecular mass of 18 is also M plus 2 isotope. That means oxygen have the isotopes of 17 and 18. So we can expect two isotopes here. So we can easily say we have the oxygen here, because the oxygen have two isotopes, that is 17 and 18. So on the basis of this isotopes, so we can say the oxygen M plus 1 peak and M plus 2 peak because of the oxygen present in the compound. So on the basis of this peak, we can say the compound is oxygen compound. So oxygen compound means the oxygen must have 16 molecular mass. Then its uh, atomic mass of oxygen is 16, and then the molecular mass of the compound is 80 from the given spectrum. Then remaining two are from the hydrogen. So here, after the addition of two hydrogen molecular mass, then it becomes 18. So one oxygen and 2 hydrogen. So it becomes water molecule as a 18. This is very simple one. You can easily expect the compound structure here. And then we have to propose the fragmentation. How the fragmentation will occur? So here we have the fragmentation. That means water molecule. So here the water molecule, they fragments. First fragmentation is done by the removal of one hydrogen, and here the molecular mass of the fragment becomes 17. After that, we can remove the another hydrogen, and it becomes the oxygen with the positive charge, and here the fragment with the 16 as a fragment ion peak. So 16 and 17 we can expect the mass spectra in the mass spectrum. So here we can easily say the given compound is water. So but we know the spectra of spectra we are dealing with the water, but in the normally in research field we don't know which compound we have. We know only the molecular mass, then ionic peak, isotopic peak, and then fragmentation peak. And then we have to guess on the basis of these steps, we can identify the compound, which compound we have. So this is the this is about the water molecule, and this is four most important question. So we have to write the base peak, fragmentation peak, and isotopic peak, and you have to explain the isotopic peak and fragmentation peak. So here we are explaining the isotopic peak here and the fragmentation peak here. So this explanation is very important. So it have 4 marks. And then we have the spectrum of ammonia. So here the base peak. So this is spectrum. Here first peak we have to identify the base peak. So here the base peak is with the atomic number of 17. So this is the base peak. And then fragmentation peak we have 1, 2, and 3 fragmentation peak. 14, 15, and 16 are the 3 fragmentation peak. Already you know the compound name, there is ammonia. We can expect which compound, which fragment we will get. So we can easily say by removal of one hydrogen, we will get the atomic mass number of 16. By removal of two hydrogen, we will get 15. Removal of three hydrogen, we will get 14 as a molecular mass peak. But we have to explain here. So already we know from the mass spectrum, but we have to explain this thing. So first step, we have to identify the base peak. So here the base peak is 17, and here the base peak and the molecular ion peak both are same. That means the base peak is 17 and molecular ion peak also is 17. So here what is molecular ion peak? That means the given compound have the molecular formula of molecular mass of 17 and its base peak also 17. So this we can easily say from the first point. And then second point, the peak observed at E by M, that means M by E ratio. Here the 18 is the isotopic peak. So the molecular ion peak is 17 as I explained in the last slide. So the molecular ion peak is 17, but we have M plus 1. That means after the molecular ion peak, we have an extra one addition. There's a plus 1 after plus 1. We will get at 18 we have the isotopic peak. So in the 18 we have the isotopic peak. The odd molecular mass. So in the odd molecular mass, 17 is the odd molecular mass. So one peak suggests the presence of nitrogen and hydrogen. That means from the nitrogen rule, if we have the odd number of molecular mass, then we can expect one, that means the odd number of nitrogen here. So from the odd number of molecular mass P, we can expect odd number of nitrogen or no nitrogen. So both are happens here. If they have the odd number of molecular mass, then we can expect odd number of nitrogen or there is no nitrogen. But here we have the one nitrogen. So one nitrogen is the odd number of nitrogen, and then M plus 1 peak suggested the presence of hydrogen here. That means the hydrogen normally have the atomic isotope of hydrogen 1 is normally normal hydrogen, and then hydrogen of molecular mass of 2 and hydrogen of molecular mass 3, like this. So we can expect here two type of isotopes of hydrogen. There's a M plus 1 is highly abundant here. So compared to M plus 2, so we have the isotopic peak of M plus 1. From the isotopic peak, we can expect there is a hydrogen may be present, and then the number of or molecular mass of the molecular ion peak of 17, we can say there is a odd number of nitrogen. So from these two, we can say there are there is maybe a nitrogen and hydrogen from the mass spectrum, and then the molecular formula of the compound is NH3, and then from these all points we can say the molecular formula of the compound is NH3. So the fragmentation, now we have to give the proof by the fragmentation peak. That means our NH3, we guess it is a NH3 compound, then we have to give the fragmentation of NH3. That means after the giving the fragmentation of NH3, that fragmentation molecular mass must match with the fragmentation ion peak of this graph. So if we have the similar, or if they both have the similarity, then we can expect the, we can say there is a ammonia compound is. So first we have to write the fragmentation. Here the fragmentation is NH3 by the removal of one hydrogen molecule, it gives NH2. Okay, that means which have the molecular mass of 16. So we have a 16 fragmentation peak. So this first one is okay. First fragmentation, we have the proof in the mass spectrum, and then second one, we can remove another molecule of hydrogen. So from NH2, we can remove one hydrogen, and it gives the molecular mass of 15. So we have a 15 fragmentation daughter peak here, fragmentation peak or daughter peak. So we can say this can possible. And then the third one, the removal of another hydrogen, it gives the nitrogen with the only nitrogen with the molecular mass of 14. So this is also possible, and we have the proof for that. That means we have the fragmentation peak at 14. So this fragmentation is matched with the spectrum here, spectrum fragmentation value. Then we can say, so the given compound is ammonia. Like this, we can give the proof. So here also it is 4 marks question. We have to write the base peak first, identify the base peak and molecular ion peak, and then the isotopic peak, and then fragmentation peak. And we have to give the fragmentation, and we have to match with the spectrum. So this much is about ammonia. And then the mass spectrum here, the mass spectrum of methane. This is also very simple. So here in the exam also, this is very important question. There's a mass spectrum of methane. Here the base peak or molecular ion peak. Here also the base peak and molecular ion peak both are same. The base peak and molecular ion peak is 16. And then the isotopic peak. Here also we have the isotopic peak. There is a M plus 1 at 17. Due to the carbon 13, the abundance is very low. The carbon 13 abundance is very low, but it gives the peak here. This is the intensity is very low here. So we can easily say the intensity is very low. This is a very small peak. And then carbon 17, that means carbon 17 is the, carbon 13, which gives the isotopic peak of 17 in the mass spectrum. So we identify the base peak, molecular ion peak, and isotopic peak. Now the explanation. The isotopic peak helps the determination of molecular formula. So isotopic peak, from the isotopic peak, we can easily identify the molecular formula. The natural abundance of carbon 12 is already explained. So the abundance of the carbon 12 and carbon 13 is in the ratio of 100 is to 1.8. That means in the 100 carbon, we can expect only one almost 1 of carbon 13. That means all other are carbon 12. That means the abundance of carbon 13 is very negligible, it's very small. So its intensity which is very low here. Therefore, for every 100 C4 CH4, that means carbon 12 molecule, there will be 1.08 molecules of carbon 13. So this is the meaning here. That means in the 100 of carbon, we can expect only one carbon 13 here. So this is the information we can get from the isotopic peak and the molecular ion peak of this spectrum. And then the natural abundance of hydrogen. That means here also the hydrogen 1 and hydrogen 2. That means molecular mass of hydrogen 1 and molecular mass of hydrogen 2. In that case also the 100 is to 0.016. That means in the hydrogen 1, if we have 100 molecule of hydrogen 1, in that we can expect only 0.016 of, that means that much of negligible amount of hydrogen 2 molecular mass we can expect. So from here also we can say there is a m plus 1 which have the very small intensity. So 4 hydrogen atom, 4 into 0.016 molecules of carbon 12 and CH4 are present. That means in the each carbon molecule we have 4 number of hydrogen. So we can say 0.016 into 4 means in that we can expect only one hydrogen here. The intensity of the heavier isotopic, that means normally m plus 1, it is heavier than the molecular mass peak. So it is equal to, we can calculate the percentage of hydrogen isotopes here. We can expect here from this formula. That means 1.08. So this is the m plus, it is the calculation about m plus 1 peak calculation. Okay, intensity calculation. So here 1.08, this 1.08 is come from carbon here, the abundance of carbon 30, and plus 4 into 0.016. That means one carbon atom here attached or bonded with the 4 hydrogen. So 4 hydrogen into 0.016 means what? 0.016 is the abundance of m plus 1. That means hydrogen with the 1, it is highly abundant. So hydrogen 2 molecular mass, it is 4 into 0.016. That their abundance is here 0.016 here. So the intensity of the molecular ion, we can say 1.144%. From this we can calculate the isotopic peak. And then this is about the fragmentation. There is CH4 plus, and then we can remove one hydrogen, means it gives the molecular mass of 15, and after removal of one hydrogen it gives the 14, and like that we can remove all the 4 hydrogen, and at the end we will get the 12 as a molecular ion peak here. So we can compare this fragmentation molecular mass with the spectrum. So here also 1, 2, 3, 4. That means 1, 2, 3, 4. 4 peaks we can expect. So this is the base peak. Then we have 1, 2, 3, 4. So these 4 are the fragmentation peaks. So this is the fragmentation, and these 4 are the fragmentation peak. And then this agrees. That means this fragmentation agrees very well with what we observed in the mass spectrum. That means we are comparing the fragmentation and the mass spectrum here. And then which contains the isotopic peak. From the calculation, the intensity is very low because from the calculation 1.144%. That means the fragmentation is almost 1.15% of fragmentation intensity, isotopic intensity. So here the isotopic intensity also, here also it's very low. Here we can see the intensity of isotopic peak also lower here. So in the calculation also we have very low intensity theoretically and in the spectrum. The both the cases they are, we can compare and they are matched with each other. So we can easily say the given compound is methane here. Then the fragment, that means at the last we have the fragment of 12, that means 15, 14, 13 and 12. So these all fragments is due to the carbon. With the removal of one hydrogen we will get CH3, by the removal of two hydrogen we will get CH2, and by the removal of three hydrogen we will get CH, and then removal of four hydrogen we will get C respectively. From this also we can say the fragmentation pattern is matching with the spectrum. So like this we have to give the evidence for the spectrum by the fragmentation, and then from the isotopic peak values, and then the base peak values, we can give the evidence for the mass spectrum of methane. And then the mass spectrum of bromine. So here the mass spectrum of bromine and ethanol we have. For the mass spectrum of ethanol, we have to solve the mass spectrum of ethanol as like I solved. Okay, this is for this homework for you. The mass spectrum of ethanol. I will explain the mass spectrum of bromine, ethyl bromide. So here it's a very beautiful and very interesting peak mass spectrum, because in the mass spectrum you can see a different types of peaks. That means these two are different here and these two peaks are different. So we can expect the different type of explanation here. So the base peak is 29. So here the base peak is 29, as we observed from the last three, or in last three examples the base peak and the molecular ion peaks are both are same. But here, but in the mass spectrum of ethyl bromide, the base peak is 29. Okay, the base peak is 29, but the molecular ion peak is 108. So what is the difference here? That means base peak means the highest intensity peak is the base peak here. So the highest intensity we can expect here 29. So it has the highest intensity, and then it is the base peak. And molecular ion peak means here which have the highest number of molecular mass. So 110 and 108. These two are the highest molecular mass. So these two are the molecular ion peak. So this is, we can say, M plus. Okay. In the before example, base peak and the molecular peak both are same, but here it is different. The base peak is 29. Okay, M by E ratio of 29, but the molecular ion peak is 108, 110. Okay, now we are identified molecular ion peak and base peak now. And then here we have very important character or an important peak, that is isotopic peak. Here we have one isotopic peak, that's M plus 2. So this is M. So this is M here, and this is M plus 2. Why? 108 is the molecular mass of highest here, M, there's 108. M plus 2 means after the addition of 2, we will get 110 as a isotopic peak. So we can expect only one isotopic peak, there's a M plus 2 here. Okay. Similarly, the same pattern is repeated in the 79 and 81. So in the pattern of molecular ion peak and the isotopic peak, we can say in the 79 and 81, here also 79 plus 2, we will get 81. That means here also the same pattern is repeated. So from these two pattern, we can say from these two pattern, the isotopes, these two are the isotopic peak. They are the isotopes of bromine here. Why it is isotopes of bromine here? Because the bromine have nearly same abundance. That means they have equal peak. That means the length of the peak in the both the pattern, it's equal. Okay. Normally in the before example, we can say we have the isotopic peak here. It's very negligible. So only 1% in the 100%, only 1% of intensity we can expect here. But here we have the 50% of expectation here. That means both the peak have the equal length of peaks. So therefore it is bromo compound. So it is bromo compound here. The peaks at M by E ratio, that is 79 and 81 corresponding. That means bromine 79 with the plus and bromine 81 with plus respectively. The peak at 29 is due to C2H5. So these two pattern is, that means 79 and 81 pattern is because of the bromine isotope. That means bromine plus here this one and this one, which gives the peak of 79 by the bromine 79 and peak of 81 is because of the bromine 81. If we have any this type of peaks in a mass spectrum, then we can easily say the given compound have bromine. Okay. So from this isotopic peak, we can easily identify the presence of bromine here. And then their abundance here also, the bromine 79 is normally 50%, and then bromine 81 also it have the abundance of 50%. So they give equal length of peaks. So they give equal length of peaks. So this also another explanation for their from their intensity. And then from these two we can say the presence of bromine here. And then the peak, the base peak, we have to give the explanation for base peak. This 29 base peak, this is because of the presence of C2 and H5. So C2H5, just calculate the molecular mass of C2H5. That means carbon 12 into 2. That means it becomes 24. 24 plus 5 hydrogen with the 1 atomic mass number. So it becomes, the molecular mass becomes 29. So this fragmentation is very common, and from because of this fragmentation we will get the base peak at 29. So all the fragmentation peak in the spectrum have the evidence. So we can say the given compound is ethyl bromide. So from this we can easily say, from the spectrum of mass spectrum we can say the given compound is ethyl bromide. And then we have the mass spectrum of ethanol. So this is homework for you. So you have to solve the mass spectrum of ethanol. In next class I will go through the application of mass spectrum. So this is the application of mass spectrum, and in next class I will explain the application of mass spectrum here. Thank you.